Okay, so looking at number 3, I am given that AB is equal to DE and BC is equal to CD, and I see those marked in my diagram as well with my tick marks. I want to prove that AC is congruent to CE. Okay, so here most of the proof's actually already given for you, but we just need to fill out the reasons, and some statements and some reasons. So I have my first two steps. So I have AB equals DE, BC is equal to CD, that's my given. And then for their second step, they stated they use the addition POE to say that this means that AB plus BC is equal to BC plus DE. So what they did was they added BC to both sides of this AB is equal to DE. So they just added BC to both sides. Okay, and then next, it says that they use the substitution property of equality. And so I need to see, okay, so from here, what can we replace? Well, I know that BC is equal to CD, so I think they're going to be replacing BC with CD in either one of these. So I need to figure out which one they're going to replace. Well, I'm trying to get that AC is congruent to CE, so I want to leave this left-hand side. And now I'm going to replace BC with CD. And again, that's because that BC is equal to CD. So I just use substitution with these two. Okay, next they state two different things. They state that AB plus BC is equal to AC, and CD plus DE is equal to CE. Okay, why were they able to state that? Well, looking at my diagram, they're saying AB plus BC is equal to the entire segment. So what's that postulate that says that two parts of a segment add up to equal the whole? Well, that's my segment addition postulate. Okay, and so now they again are using substitution POE. I know I want to somehow get that AC is congruent to CE, so I want to say that this is going to end up being AC is equal to CE, because that's going to lead to that. But now let's look at C. Why were they able to do that? Well, we have that AB plus BC is equal to AC. CD plus DE is equal to CE. And we know that these two are equal to one another from step 3. So that's why they're then able to say that these two are equal to each other. And then to get to this final step, since they're equal, that means they're congruent. And again, that's definition of congruence. Okay, let's do one last proof. This one's also going to be a little bit longer. So I'm given that angle 1 is a right angle. I want to prove that angle 2 is a right angle. So I'm going to start with my given. And I want to prove angle 2 is a right angle. Okay, so my first step is I like to go ahead and just use my definitions right away. So I know that angle 1 is a right angle. What does that mean? What's the definition of right angle? That means that the measure of angle 1 is equal to 90 degrees. But now I need to somehow involve angle 2. How am I going to involve angle 2? Well, let's look at my diagram. So I have this line here, and I have these two angles. Well, what can I say about these two angles? Well, these two angles form a line, so I know that they form a linear pair. So I know that angle 1 and angle 2 form a linear pair. And that's just my definition of linear pair. And now from linear pair, we can make several sequence of statements from that, like we've done in a lot of other proofs. So linear pair, what do we know about linear pair? Well, we know that means that angle 1 and angle 2 are supplementary. And that was just our linear pair postulate. And what do we know about supplementary angles? We know that supplementary angles means that they add up to 180. So that means that measure of angle 1 plus measure of angle 2 is equal to 180. And that's just definition of supplementary. So anytime you see a linear pair in your diagram, you can automatically end up making these three statements. First stating they form a linear pair, then stating they're supplementary, and then saying that they add up to 180. Okay, so I have an equation here. Now I just want to get somehow the angle 2 is a right angle. You can even start working backwards here. So I know in order to say that angle 2 is a right angle, I need to somehow get to that measure of angle 2 is equal to 90. And so now I need to somehow fill in these two gaps here. Well, I know that measure of angle 1 is equal to 90. We already stated that. So I can actually substitute that in to my equation. So instead of measure of angle 1, I'm going to replace that with 90 plus measure of angle 2 is equal to 180. And there again, I'm going to use substitution. So I just replace these two. And now how can I get measure of angle 2 by itself? Well, now I can subtract 90 from both sides. And so that's my subtraction POE. And so when I simplify, I get that measure of angle 2 is equal to 90. And therefore I can say that angle 2 is a right angle by definition of right angle.